Good morning, good afternoon, or good evening, depending on where you're tuning in from, and welcome to today's Dot3D Pro webinar covering our new volume calculation functionality built into the latest releases of Dot3D. Today we'll be walking through a do-it-yourself cut and fill project that was recently executed on a home renovation or home improvement scenario, as well as some other volume calculation functionality, including live demonstrations and even some live scanning in the second half of the webinar. While I expect everything to go smoothly today, please bear with us as we do demonstrate all of this functionality live in action across multiple locations. And please feel free to submit any questions throughout the presentation. We will be reviewing all of the questions at the end of the presentation. And if we don't have a chance to get to all of them, we will absolutely be following up via email as well. So with that, I'm gonna move ahead to introductions. Myself, Chris Ahern with DotProduct. Marketing, sales, and product manager here in Boston, and pass it off to Tom, who will be taking the lead on most of this presentation as he was chiefly involved in the project.
Hi, everyone. Tom Greaves here. Thanks for joining us today. This project all began out of the COVID-19 virus disrupting my personal plans. So I'm going to jump right to the very end result. This is a patch of gravel beside my driveway. And sitting on top of that patch of gravel is a 7.5 ton boat. And usually this time of year, that boat lives in the water. But because of the virus, it's a long story. I couldn't get to Maine, so I had to bring it to my home for the first time. So what this project involved was putting down that gravel and the right amount of gravel. So let me get on with it. I live on some very soft ground. You can see an image here of the ruts caused by the truck that hauled the trailer that brought the boat to my house. It carved some deep ruts, and so the ground was very, very soft. And I knew beforehand that I wasn't going to be successful if I just put the boat on top of the soft ground. It, could sink and into the ground, and it'd be really difficult to lift it up in the spring, and also some risk because it could fall over. So I had to put down some gravel. So to do that, I went to the nearby Grand Central rental place and rented an excavator. And there's my son Garrett. He and I dug this patch out. It was approximately 15 feet by 25 feet by 9 inches deep. And my apologies to those of you who prefer the metric system. I'll have some conversions for that later. But it was a small patch, and this took us a couple of hours. And I have to say it was a lot of fun. Neither of us had ever operated one of these pieces of equipment before, so it was definitely a steep learning curve. And my hat goes off to the people who do this for a living. They have very fine control over the bucket on this pieces of equipment like this, and we were rank amateurs. But eventually we got it. It took us a couple of hours, and this is what the result looked like. It was a hole in the ground, 15 feet long, or 15 feet wide, 25 feet long, and approximately 9 inches deep. And I have some architectural, or not landscape tarp over the top of it, and this is to prevent weeds from growing up through the gravel, when it's covered up. So I needed to calculate how much fill, how much gravel to order. And to do that, I scanned it. So I'm going to switch screens here, and let me just pull up the raw scan data. This is the scan data that I took, and I used a DPI 10 to capture this. And I'll show you the rough measurements here. So pick a point here. Oh, we're going to measure, a distance. So I've got, I already had a measurement up here. So you can see it's 15 feet this way roughly, and approximately 25 feet in this direction. And when we staked it out, we were aiming for a 9-inch depth. So this took about a minute or two to capture with the scanner, really quick. I could have as easily done it with the Intel RealSense D415 on my phone. In fact, I did do some scanning with that later, and I'll show you that in a minute. But the task in front of us here is to calculate the volume of that hole and then order the correct amount of gravel. So to do this, we're going to use the fill volume measurement tool. And the first step in this is to create a plane. And what we're going to do is measure the volume between the plane and this, the bottom of the pit. So I picked a point around here. That's where the plane is. And then I have to draw a polyline to define the volume that I want to measure. So I'm going to pick one here, first point here. And I've got the little magnifying glass in the upper right-hand corner. And then we'll go over here, actually about here, and here, and here. Okay. So, and we can move these points around if we're not totally satisfied with them. But it's something like that. Maybe I'll just pull this one back a little bit. And then we get to measure. So I look at this and it doesn't look too bad. It's a little low, particularly back in this corner. And as we all know, 4 points don't define a plane, 3 do. So this is, requires a little tweaking. But, we'll go up about, let me just go up. I think that's pretty close right there. Yeah, I like that. So I get a volume of 260, maybe it's a little low in that corner. Might come up just a hair. Yeah. So it's a little high on this end and a little low over there. We will have some tilt controls in the future. So this is approximately the volume. I get 265 cubic feet. And you can see there's a little manual adjustment to it. So let me go back and to the PowerPoint, and I'll show you the results that I ended up using after some tweaking. So this is a table of the results that I obtained. So the design, or the plan, was 15 by 25 feet, 15 feet by 25 feet, or surface area 375. And here I have the results expressed in square meters, and the depth of 9 inches, or 0.23 meters. And this came out to a volume of 281 cubic feet, or 7.9 cubic meters. And then when I measured it with our software, I got these results. So they were within about 2% of what I planned. And so I thought that was pretty good. Based on this, I ordered 15 tons of a material called 3/4 inch pack gravel. And that's aggregate that will fit through about a 20 millimeter sieve, or a 3/4 inch sieve. And the conversion factor provided by the gravel supplier, it turns out you order gravel by the ton, not by the cubic yard. It's a weight measurement. And it turns out to be 1.4 tons per cubic yard. I ended up ordering 15 tons, a little bit over. So I subsequently found out that the conversion factor is based on uncompacted gravel. So I probably should have ordered even a little bit more, but I was pretty close. And let me show you that. So here's the fill part of the operation. And I have to say, it's a little daunting when you order 15 tons of anything, have it show up in your yard. But the gravel truck operator helped me quite a bit by spreading it out. But there was still quite a pile to spread, and between my son, who's got all the muscles of a 20-year-old, and my 18-year-old daughter and me, we got it all distributed that morning. I won't. So this is what it looked like after it was spread and compacted. I didn't have a compactor, so I just drove over it with my SUV. But you can see that I think we got it about right. You know, it's level here with the driveway, which is what I wanted. And at the back and all four corners, it filled in about where I wanted it. And very happy to report that the boat did not sink into the gravel. We had some rain since then, some heavy rains actually. So this worked out. Let me show you a sample data set from the RealSense scanner, because I scanned the area just yesterday actually with the D415 sensor out using my phone. So there it is with the boat in place. And I didn't scan the whole pit. I could have easily done it, but this is perfectly adequate for doing the kind of measurements that I was doing here, just measuring some volumes. So the takeaways for me are that you know, you can use a handheld scanner for small projects like this and get accuracy of order of you know, a few percent. And for this kind of work, that seems to be just fine. Fast and easy. Obviously, this is kind of a special project. You know, it's a homebrew project, but we do have some customers that are very interested in doing this on a commercial basis, you know, measuring pothole volumes or volumes of excavated material on construction sites. Now, obviously, you're not going to do a 50-mile trench with this, but for small projects, it seems like a good way to go. So with that, I'm going to turn this back over to Chris, who's going to show you some other variations of the of our volumetric measuring capabilities. Back to you, Chris.
Perfect. Thanks a lot, Tom. So with that, I'm going to switch the presenter over to my DPI 10SR tablet, same model that Tom actually utilized on this project, and demonstrate some live scanning and additional volume calculation functionality. All right, so you should all now be able to see my Android tablet screen. I happen to be using the Android model today, where I've pulled up Dot3D Pro. Now, this scan is going to be of a piece of furniture in this case, relating in some ways to the home improvement type work that we've shown so far in the webinar. And I'm going to be scanning an irregularly shaped piece of furniture to try and get the bounding dimension calculation. So the length, width, and heights. For example, if you needed to fit this into a box, or if you wanted to fit it into a storage unit or otherwise down a tight corridor into a facility, this has a lot of different applications. The warm-up period recommended for your first scan of the day with the DPI 10SR is a 15-minute warm-up, which we recommend following whenever possible. In this case, we're going to bypass that for timing constraints. So I just press the button on the right to start my scan. Additionally, I just wanted to include this as part of today's presentation for anyone who's new to our technology to see it live. It's always great to see live. The green and yellow is real-time feedback on the quality of the points that we're collecting. So green is great, yellow is good. You basically just spray paint the areas of most importance and fill them in real time. The target you see turning orange on the screen is called an April tag target. And this has a lot of powerful functionality, but in the simplest manner, if you put one in your scan, start at it, and finish back at it, it's going to automatically improve the accuracy behind the scenes. So I'll start at that tag and I'll finish back at it. And I'll get a quick scan of this papasan, you know, irregularly shaped piece of furniture in a matter of a minute or two. The short range model is our close range version, which gives you the best capture capabilities for objects or equipment, anything you want to get nice and close to it as the best discrete detail, which is why it's a great fit for capturing a piece of furniture. So I can reach underneath and get all those hard to reach angles very easily. And when I'm happy with my scan, I finish back at that same target and press the button on the right to finish the capture. Now we have our quick unoptimized preview of the scan. This is a chance to take a look at the data and make sure you got everything you need. This is by no means the final result, but it's a quick chance to check what you had, make sure you don't need to use the append feature to add anything in. So it looks like we got a very complete scan of the chair, and I'm gonna go ahead and move forward with the optimized functionality. I automatically have the boxes checked to use April tag, so this is taking into account that tag on the floor, and also to apply color leveling, which is a new option in the very latest release of our software 3.3.3, which is about to hit shelves. In 99.9% of cases, you're going to leave that checked. What that means, it's leveling the colors throughout the scene. So it's making sure that the colors blend nicely as you captured the same objects or surfaces from different angles and different distances. Otherwise, during the optimization, we're tightening the frame-to-frame alignment based on overlapping frames, based on any of these targets you have in your scene, implementing any other constraints that you may have utilized, such as the plane picking functionality, and cleaning up any noise or stray points that are recognized in the scan. And you'll see that as soon as this finished optimizing, it's going to look a lot better. It's going to be nice, clean, bright colored data that's been leveled throughout. This is something that can be done immediately on the tablet like we're doing now, or it can be saved and been taken care of later after the fact. As soon as you finish scanning, that unoptimized scan has already been auto-saved onto your hard drive. So now before we move forward with the volume calculation functionality, typically the first step is to crop out any stray data. So these other pieces of furniture that are irrelevant to what we're doing here, we'll quickly clean those out. So I do edit, crop, and then I do want to make sure to keep some of the floor, so don't crop too tight because that's part of what we're using here for this volume calculation tool. And I'll do select, invert, and then it's everything in red that I'm getting rid of, and hit crop on the bottom right. Now that I've cleaned up my scan, I want to get the length, width, height, and volume measurement of a cubic box, basically telling me what size box I would need to fit this piece of furniture. So I go to edit, measure, and instead of the fill volume like Tom did earlier, we're going to do the bounding dimensions tool. And then we're basically just going to, again, follow the instructions on the bottom of the screen. So press and touch on a portion of the floor to set that as your ground level. Then it'll automatically give you a top-down view. And you want to set this box to fit as close as possible to the object that you're measuring. It by no means has to be an exact fit. That's what the software is going to take care of for you. And once you're ready, you just hit Fit Bounding Box on the top right. That'll automatically give you the minimum dimensions that you would need in terms of a cubic box to fit this equipment or a piece of furniture, in this case, in the units that you specify. So you see shown on the screen, we have the length, the width, and the height, as well as on the right side of the screen, the cubic volume. We can change that to feet, for example, 33.5 cubic feet. So this is a really useful tool in the logistics and shipping worlds, and could absolutely be helpful in the moving or home improvement realm as well. We expect to continue to build on both these volume functionality features and add more as the needs arise from our customers. So with that, I think we're going to go ahead and pull up some of these questions and move through as many of them as we can before closing out the session. So this is a question for you, Tom, regarding the fill volume functionality. When you set the plane, can you pick more than 4 points? How big the area or how deep can the excavation be suitable for the measurement? So I guess that's a two-part question. First being, can you select more than 4 points?
Yeah, you can select a polyline around there, and so as many points as you like.
Definitely. And then how big of an area or how deep of an excavation would be suitable for this measurement?
So that's a very good question. The maximum range of the sensor is about 10 to 11 feet, 10 to 12 feet. So you wouldn't want to do anything deeper than that unless you're prepared to get into the volume itself. You got to get the scanner so it can see the bottom of the pit, if you like. So that's on the maximum end, and on the minimum end, you probably wouldn't want to do anything shallower than I'm going to guess a half an inch or a couple of centimeters, something like that. It just wouldn't make sense.
Sure.
Maybe a centimeter. If you're up close to it, that would give you a meaningful result. Obviously, you need to be a minimum distance of about 2 feet away from the bottom of the pit. And at that accuracy, we're looking at, a couple of millimeters of range noise. So, yeah, 1/8 inch, it really wouldn't make sense to do much less than, half an inch depth.
Got it. Next question here. You mentioned that this could have been done, with a phone, even using the D415. And the question is, what type of phone would you need to do something like that?
Yeah, so any reasonably new Android phone. The phone that I used was a Samsung Note 9, so that's about 2 years old. You just need to have a USB port with USB-C 3.x, I think 3.0 or 3.1. So it needs to be USB-C connection to connect the sensor. And on that, you should also make sure that you have the right cable. So we've had some support questions related to that. It turns out that not all USB-C cables are the same. Some of them only support some older 2.0 protocols. So check with us. We can give you a link to Amazon. You can buy one yourself, or you can buy one from us. But make sure that you have the right cable. So the short answer is, any reasonably new Android phone will work as long as it has the right kind of USB-C port.
Great. And then similarly, the next question here is, as you mentioned, this was done with the DPI-10, and it could have also been done with the D415. And what would be the differences in terms of capture or the resulting data between those two options?
So a couple of things. I did this, I can't remember whether I did it early in the morning or I think it was late in the afternoon. So the sun was low on the horizon. So I was able to use the DPI-10 with the Carmine sensor. And typically the Carmine sensor, it will not work in direct sunlight. So one advantage of using the Intel RealSense D415 is you can capture in sunlight. So you can see the very last screen. Maybe, I don't know, Chris, maybe I'll share my screen. Can you make me the presenter?
You are the presenter, so you should be good to share your screen. There we go.
Okay, so this data set here was captured with the D415, and you can see from the shadows that it was a bright sunny day. So the advantage of being able to, doing this with the RealSense, on the phone, is that you can capture in direct sunlight. And for this kind of application, that's often a huge advantage. The accuracy of the RealSense sensor is of order of, plus or minus 1 to 2%. So you give up a little bit of, whereas with the DPI-10, it's more like a plus or minus 0.5%. So you give up a little bit of accuracy for that daylight capability, but for this kind of work, it really, it's immaterial.
Got it. Let's see here. I don't know if this was touched upon or not, but it's how long did it take to scan the hole that you ended up filling in, Tom?
About 2 minutes.
Yeah,
I just had
so not
yeah,
much time at all.
yeah, it was, it took me longer to walk from my office, in my home office to the pit than it did to actually scan the pit. I mean, it was just really fast.
Sure. This is a question for me, asking. I'd mentioned that you can optimize on the tablet or off device, asking, why would you would pick one or the other. So with a small scan like the one I just did, it's really easy to do right on the tablet. Obviously we saw that process live in probably 20 seconds. But if you're doing a much larger scan, then you oftentimes might want to offload that processing either to on the same device at a later time, or the best bet is to do it on a laptop or PC. And you can even do a bulk optimization where you select, say, 10 scans and just let them all optimize. Because with larger scans, they could take up to 5 or 10 minutes potentially, and that's with much larger scans. But it's good to have that option, and that would be using a Dot3D edit license, which is our very affordable edit only version of the software that you can add to as many Windows or Android devices as you'd like.
I'll just add to that. We have a customer that scanned the deck of a ship, and they created a 157 megabyte file. That was probably the biggest one I've seen, and it took about 20 minutes or 25 minutes to process on a pretty fast PC. So it would have taken an eternity on the tablet. So often if you're capturing very large scans, working on a desktop can be a real plus. And I will say that in our development roadmap, we have some plans to exploit multi-core capabilities and multi-thread the problem so that we can speed up this processing time. You'll see that going forward.
Definitely, and along those lines, it's really good to know when you're scanning that as soon as you finish capture, it's already been backed up in that unoptimized format. So whether you're optimizing it on device or off device, you already know you have everything saved and backed up immediately locally. Let's see. Last question here. Yeah, go ahead.
Yeah, just another aspect of that. If access is really difficult, if you're not going to be able to go back and get the data again, I hope this never happens to you, but sometimes it just gives you a little peace of mind to do the optimization in the field to know for sure that when you leave, you got what you think you have. And this is one of the unique advantages of Dot3D Pro is that you can get the answer in the field on the spot before you leave the site. And consequently, avoid a rude surprise the next day. For example, finding out that you thought you captured something, but in fact you hadn't.
Sure, definitely. Last question here is just asking what the other buttons were on the screen while I was scanning, which I didn't actually utilize today. So there's two other features that you can take advantage of currently while you're capturing, and that is the plane picking functionality and the HD photo capture functionality. So the plane picking, I could have used today on the floor around the piece of furniture, but it's much more relevant over larger area scans. And what that allows you to do is to flag any level surfaces as being such while you're scanning. So imagine you're in a congested room with a lot of equipment and you're moving through a much larger area. Anytime you tap and flag that floor as a plane, it's going to make sure that that plane is locked in as level across different points in the scan. So similar to the targeting workflows that we have, it's an additional piece of information that the software takes advantage of automatically to improve the accuracy of your data. The other option that we've shown in some of our other webinars is the HD photo capture functionality. So this is what's allowing you to access the high resolution 2D camera of your tablet and then capture those much more detailed images while scanning and have them then pop up in your 3D scan environment showing you where you were standing when each of those images was taken and what direction you were pointing in. So I think that covers, yeah, the question here of what those buttons are for. I think we're gonna close up shortly here. Just taking a look to see, it looks like we have actually had a couple more questions come in. So the next question is if it will be possible to do the volume for an irregular shape. Not using a polyline, but a box shape. If I understand the question correctly, it's asking for, something in between what we've shown today. So we got an irregular calculation of a hole. We also got a length, width, height calculation of a piece of equipment or a piece of furniture. And I think this may be asking if we could get the volume of, the actual inside containment of an object, for example, or a room. Not yet, but I think that is something that we may add in the future, because it doesn't seem to be a far stretch from what we already have.
Yeah, on that note, if this webinar has kicked loose any, suggestions, we would be very receptive to that. This is a new capability for us, and if you have any ideas about how we can improve this, please let us know so that we can get this on our to-do list.
Definitely, and to do so, please respond directly to any of your reminder emails about this or the one that'll go out tomorrow. If we have 2 scans from a room, can we append them later on at a later moment, or use the append function must be done at the moment? So just because we didn't really discuss the append function that much today, I'll just mention what that is. That's the ability to, after you've finished one scan, to go back and add more data, either into the same scan file or add a new scan into the same coordinate system. And it does not have to be done at the moment. It can absolutely be done at a later date or time, as long as there is an area of your scan or a frame of data to point at that hasn't changed, which, it doesn't, even if other things have changed, you just need to lock into a point that hasn't changed, which is usually not a problem. What file format can this be exported to be consumed by other software? Yeah, we can pull it up on the screen. Perfect, Tom. So by default, we export to the .dp format. That's our highly compressed native point cloud format, which is oftentimes as much as 40 or 50 times smaller than the other standard point cloud files. So it makes things really fast and easy, both on your scanning device and in post-processing. We have about 30 partners so far in terms of CAD applications like Autodesk Recap or point cloud processing tools like Cloud Compare. And then also actually the whole line of Autodesk products with their RCS export, meshing tools, et cetera, that'll read that DP format directly. But then we also export to 9 other formats to maximize compatibility across the board. So you see them all listed out on the screen here: E57, POD, LAS, LAZ, PLY, PTG, PTS, PTX, and RCS, which will go straight into an attachment in an Autodesk Revit, AutoCAD, Inventor, Navisworks, et cetera, project. So really direct from scan to CAD. So virtually any application that works with laser scan data or point cloud data should work with one of these formats. So this kind of relates to what we touched on earlier. Can I scan a complicated engine room and then download the scan onto a laptop to calculate the data to make sure I've captured all the info I want? So the short answer is yes. And the longer answer is that you would want to have a Dot3D edit license on your laptop, but that's as affordable as $10 a month. So it's a very easy add-on to complement your license for your scanning device. Your Dot3D Pro license does include all edit functionality as well, so you can do that on your tablet, but oftentimes it's a lot more practical to do it on another device, and that's a very affordable add-on to activate that capability.
What we can do, Chris, is send the person who asked this question a link to our webinar that we did where we scanned an engine room on a tugboat. That's a real example of that, and how you could use this tool to scan an engine.
Great. Lastly, do you have any tips on establishing a level plane if you want to understand the existing slope? Level as in level with the world. You can introduce a level plane into your scene, whether that's a box that you set down or anything that has a level plane. It doesn't necessarily have to be the floor or the ground that you're pulling from. So it is possible to put something in your scene to establish that. Or if you're really trying to, establish level, in terms of gravity, you could suspend a plane. And that I think would be another option. And then that's establishing the slope of the plane. And then once you, get into your adjustment like Tom did, you can move it up and down to make sure that it fits into the elevation that you prefer. All right. Lastly, we see iPad Pro support, please. So we hear you, and we're excited to see more and more depth cameras being built into devices that can hopefully be powered by our software in the near future. So that covers most of them. If we didn't get to any of your questions, like I said, we'll be following up with all of them via email, and feel free to respond directly once you see that or beforehand if you have any more questions. So thank you, Tom, for an excellent presentation on this application. And thank you to everyone else who has been on the line today. We appreciate your patience through the hiccups at the beginning, and we're glad to have so many of you on the line for the duration.
Thank you so much, everyone. And welcome any of your questions offline.